Good evening everyone. In this video, I'll be discussing about client-server paradigm. So we'll be looking at what is client-server paradigm. Of course, we have already checked it. So we'll be looking in detail, okay, here. And we'll be looking at client-server applications and services, okay. We will also discuss a service session, okay. So what is the communication between the client and server, okay. And the protocol for a service, okay. So we'll be looking at all the concepts as part of this video. So we have already discussed this one. The client-server paradigm is the most widespread model of distributed computing protocols. Okay, and it is the basis of all the distributed computing paradigms at a higher level of abstraction. We have seen the paradigms for distributed computing, and we have seen their level of abstraction from high to low. And client-server actually is actually here. Okay, of course, along with peer-to-peer as well, which will fall at the same level. Okay. So the client server is service-oriented architecture. It actually employs a request response protocol. So we already discussed what is client service-oriented architecture. Okay. So request response protocols also we have actually discussed in simple. Okay. So we'll be seeing more of these things today. So when you think in terms of the client server paradigm, there is a server process, okay, which is running on a server host. So the server processes, okay, so multiple server processes are running on this sort of server host, okay, and these things actually provide access to this particular service. So the service which is actually running on the server host is provided access by this process which is actually running on the server host in that case. When a client process which is actually running on the client host in this case, okay, so it can actually access this service via this server process. That means when this client host actually want to contact this service, interact with this particular service, it will always get the access through this server process. So this interaction of the process actually proceeds according to a particular protocol. We'll be seeing that what these protocols are in the coming slides. So an application which is actually based on this sort of client server paradigm, it is actually called as client server application. On the internet, many of the services, whatever we are seeing, okay, they are actually based on client server. So they are actually client server applications. So these services are often known by the protocol that the application actually implements. So well-known internet services here are HTTP, FTP, okay, file transfer protocol, DNS, all these things we have already discussed that. Okay, so these are about the standard services which are actually available on the internet. Even user applications can also be built using this sort of client server paradigm. So client server as a keyword has been used extensively. Actually, it is used in different contexts. Actually, it clutters the thing, how it can be actually used, and then it confuses you a lot. Okay. If you are thinking in terms of a system architecture, then if you are talking about client server, then you are actually talking about the computers. So for example, client server architecture, 3-tier architecture or n-tier architecture, they're whatever the clients and servers, whatever we are talking about, are about the computers. So a 3-tier architecture, say for example, there is a client, there is an application server, okay, and then there is a database, okay. So then, say for example, the RDBMS is also a server there, okay. So we have this sort of 3-level architecture, okay. So there, if you are talking in terms of this sort of client server, in terms of system architecture, then you are talking about computers there. But when we are talking about this client server in the distributed computing paradigm is concerned, the client and servers actually refer to processes, and we have been seeing these processes. Okay, so in distributed computing paradigm, so it is always the processes. So looking at both the architectures again, okay, so if you are talking about this sort of client server system architecture, the client host, that is the machines, are actually trying to make use of the services that are actually provided on this sort of server host. Say for example, the server host may provide access to a printer, okay, or some other type of service, okay, so it can be physical service as well. So here the server is a machine, okay, it's a host. A client is also a host here. So that means here we are talking about nodes here, computers here, okay. Whereas as I mentioned, when we are talking about this sort of client server distributed computing paradigm, okay, so here the client processes make use of the services provided on the server, and basically we get access to these things through the server processes. Okay, all these things are actually running on the server host. So that's where like that slight difference between this sort of, when we think of client server in terms of system architecture and in terms of distributed computing paradigm. So as far as this course is concerned, especially this chapter is concerned, like we will be talking about this sort of client server as a distributed computing paradigm. In the context of a client server model, whenever like this sort of client is actually interacting with the server, that is actually refers to as a session. So basically like session refers to this sort of interaction between this sort of server and one client. So people who are already aware of internet based applications are like people who have taken the courses like internet technologies. And if you have already worked with servlets, of course, like I quickly introduce servlets in chapter 1. Okay, the assumption is some of you know about these servlets. Then if you remember, the interface HTTP session, okay, so from this javax.servlet.http package, which is actually representing a session between this sort of HTTP client and a HTTP server. Okay, so basically the session actually refers to this sort of interaction between the server and one client. Okay, the service which is actually managed on the server may be accessed by the multiple clients who actually deliver the service, and several times like these people are actually trying to interact with it concurrently as well. Then each client which is actually being serviced by the server actually engages in a separate session with that particular server. So for each and every client which is actually trying to communicate with the server, okay, so you have a session established. So within that particular session, that particular client actually conducts this sort of dialogue with the server until the client basically has obtained all the service whatever he has actually required. Okay, that's the fundamental idea. So there is a server existing, okay, there is a client existing, and the client, whenever he is trying to interact with a particular server, okay, so it is the session which is actually established. Okay, that's about this service session. So if you really think in terms of the execution flow of a server, okay, so the server first will start this sort of service, and it actually accepts any client's request for a session and conducts a session with that particular client. And we already have seen like if there are multiple clients coming, and say for example even they are coming parallelly, okay, so then the server has to support all these clients, and then like it will have several sessions each for one client. Okay, so that's about this sort of execution flow of a server process. Then actually whenever like this sort of client and server are actually communicating, a protocol is actually needed to specify the rules. Okay, and these are the rules which are actually to be observed by the client and the server during the conduction of this sort of service session. So a session is established, okay, but then like during the session, like the client and server are actually communicating, so they actually have to follow this protocol. So both client and server has to basically follow this protocol. These rules generally include specifications on the matters such as how the service is to be located. Okay, so this protocol actually has to specify, and the sequence of this sort of inter-process communication. So who is communicating first and who is communicating later. So all this sort of communication has to be defined. Okay, the sequence of inter-process communication is to be defined by the protocol, and of course, like it should also include information about the representation and interpretation of the data that is being exchanged with each inter-process communication. So within a protocol, like there can be several inter-process communications happening, okay, and then like these protocols should also represent like what is the data like you are actually exchanging, okay, and how it is to be interpreted, okay. So both the things are to be mentioned, okay, along with this sort of addressing the service and then like the sequence of inter-process communication. So on the internet, such protocols are actually specified by these RFCs, request for comments. Okay, so literally almost all the network protocols have their own RFCs. Okay, so on the internet. So let us look at the things which are to be defined by the protocol one after the other. Let's first look at like how to actually locate a service. So a mechanism must be available to actually allow a client process to be able to locate this particular server for a given service. Okay, so the protocol should actually specify that one. A service can actually be located through the address of the server process. Okay, so in terms of the host name and the port number, okay, so that is actually assigned for that particular server process. We can actually use that information to be able to locate that one. Then the service is actually a static service. Okay, this is the scheme used for most of the internet services. Each internet service is actually assigned to a specific port. Okay, and it will be assigned a specific port number. That means like that particular service is running on that particular server on that particular port. Say for example, well-known services such as FTP, HTTP, Telnet, these are all assigned default port numbers reserved on each internet host for that particular service. While discussing the basics of the networks, okay, so we already discussed these protocols, okay, and we also have discussed like port numbers, certain port numbers 1024 ports are actually reserved, okay, so these are the reserved port numbers which are actually used for this sort of standard services, okay. So for example, FTP actually uses port numbers 20 and 21, okay, so it actually uses two ports, one for sending the control signals and another one for accessing the files actually, so file data, okay. And then like HTTP actually uses port number 80, okay, and then Telnet uses 23, SSH uses 22, okay. So most of these services, standard internet services, are actually running on particular device, okay, and on a particular port. Now if you want to locate that particular service, okay, so all you need is the particular host name and the port number, and you automatically know like what service is running there, whether that service is running there, and whether that service can be interacted, and you can actually interact with that particular service by establishing the session, the way like earlier we have actually talked about. Of course, at a higher level of abstraction, the service may be identified using a logical name registered with a registry. Okay, so we already discussed about service-oriented architectures. There we have actually talked about how we can actually register a service with a registry. Okay, in the similar way, like this sort of this higher level abstraction, the service may be registered with that particular registry. Then you can actually identify it. Okay, with that particular logical name. Then the logical name has to be actually mapped to this sort of physical location of the server process. Okay, if you have this sort of logical association possible through a registry, okay, then the mapping can be performed at runtime. And if the mapping is performed at the runtime, that is when the client process is actually run, then it is actually possible for the service location to be dynamic or movable. Okay, so dynamically you can actually find the service. So that's about like addressing the service. Okay, so how to locate the service. Then once you have located the service, okay, so you need to have this sort of inter-process communication, okay, between the client and the server. The protocol has to define this one as well. Typically, the interaction of a client and server processes actually follows some sort of request response pattern. When we were discussing about the sockets, we were already following this one, the request and responses. Okay, so at that time, like I didn't tell like this is the client and this is the server. Okay, typically, because like I wanted to discuss the client server paradigm individually of its own. So when we were looking at the socket programming, in fact, actually, both these processes are acting as client and servers. So there I actually used as requester and respond. Okay. Typically, when the client and server are actually interacting, so the client may send a request, okay, request 1 in this case, and he may get a response 1, okay, and then like he may send another request 2 and another response, and this communication basically may happen until like it is actually closed. So this is all part of a single session actually. Okay, as we have actually defined here, the session is actually established between one client and one server. And the whole of this sort of protocols inter-process communication is happening within that particular session. So regarding the implementation of a service, okay, so once you have defined this sort of IPC, okay, inter-process communication between this sort of client and server, any implementation of the client server program for this particular service is expected to adhere to the specification for the particular protocol. So the whatever the specification that is defined for that particular protocol, all the implementations of the client and server programs must adhere to this. Okay, including how the dialogues of each session should actually proceed. So everything should be exactly followed. Okay. So among other things like this specification actually defines which side, whether the client or the server should be speaking first, okay, and it should also define like the syntax and semantics of each and every request. See, at the protocol level, we are defining like, okay, so the client should be sending a request and the server should be responding. But which side should speak first? Okay, and what is the syntax and semantics of each and every request, and what is the response like you are actually getting. And of course, like say for example, once a request comes, how the server should react, and once the response comes, how the client should react. The action expected of each side upon receiving a particular request or response is also has to be defined by within this specification. So there can be several inter-process communication sessions. Okay, so examples. So the dialogue in each session actually follows a particular pattern. Okay, prescribed in the protocol specified for that particular service. Say for example, one of the well-known protocols which we'll be studying a lot as part of this chapter is this daytime service. Okay, the idea is very simple. Okay, so there will be a client. The client will be asking the server, okay, can you please give me the daytime? So the server will basically provide this sort of timestamp. Okay, it's very basic protocol. Okay, and these services are still provided on the internet, and we will be implementing this daytime service as well as part of this chapter. Okay, so let's look at this sort of the dialogue that is happening as part of this protocol. Okay, daytime service. So the client will basically ask like hello, and it also has to give its address, because like the server need to respond back. So there is a client and there is a server. Okay, so the client will basically say like hello, and this is my address. The address is to be sent by the client. Okay, and then the client is actually asking like, may I have the timestamp please. So this is basically like one request which the client is actually sending with all the information. It is saying like hello, I'm here, and then like who am I, so the client address, and also like can I have the timestamp please. So the client is actually sending all this information. Then the server will be doing is like here it is, and then like it will be sending the timestamp. This has only one request and one response. Okay, why the client has to send the address is, okay, so if the client basically won't send the address with whatever the things like you have learned as part of the course as of now, if you need to establish this particular protocol, this particular service, okay, all you have to use is then a TCP connection. So that means like you need to use this sort of stream based sockets, because like you don't have the client address. But if you send the client address as well, then you can work with the datagram packets as well. Okay, so that's about the daytime service. Similarly, like you can think of World Wide Web session. So the client basically will ask the server hello, and it is sending this address again, this client here. Okay, and the server basically says like, okay, I'm a web server and I speak protocol HTTP. Okay, in this case like HTTP 1.0. Then client basically says like, great, please get me the web page which is like index.html at the root of your document tree. So the client is sending another request. Then the server is actually responding again, okay, here is the page you wanted, and then like it basically sends the content. See, in this particular service, okay, so here the client is sending one request, it is getting one response, then it sent the second request and it got the response again. Okay, so basically like these sessions in this particular inter-process communication, it depends on the service and how many requests should be going, how many responses should be going, how these things basically coming, and which one should be going first, and everything is defined in the protocol. That's great. So we have seen like how to identify the service, and then like we have actually seen like it basically this sort of inter-process communication actually has to follow a particular protocol. Okay, this is what is actually defined in this particular protocol specification. The protocol will also be telling like, okay, so what is the data and how it is actually represented. The part of the specification of the protocol is actually the syntax and semantics of each and every request and response. What is the message like which should be there in the request, and what is the message which should be there in the response is already defined in the protocol. We have already seen this in detail in the HTTP protocol when we were checking that one. So exactly it defines like what the request should be, along with all the headers, requests and everything, with all the body. Okay, and at the same time for the response as well, like it has to define all the headers, okay, so all the body and everything, okay, including top level, so the basic request and the response. So all the semantics for that particular messages which are actually being exchanged during this sort of request and response are already specified in the protocol. The choice of data representation in such a case actually depends on the nature and the needs of the protocol. So most often, like, these protocols actually define this request and response in the form of text characteristics. It is very common. HTTP, we have already seen, like, it follows this sort of text-based protocol. Why we actually use this sort of text-based protocols is it actually facilitates data marshalling. Data marshalling becomes really simple here and allows the data to be readable by human as well. Okay, human can also read. That means, like, debugging and checking this network data, whatever is actually going, is relatively easy for you. Okay, most well-known internet-based protocols are actually client-server. Okay, and they are actually request-response protocols, and they are actually text-based. Okay, the way, like, I actually talked here. So most of these protocols are actually like this one. So HTTP is one, FTP is also the same. Okay, DNS is also the same. Okay, most of these protocols, well-known internet protocols, are actually based on this client-server model. Okay, and they are text-based. So regarding the reference are concerned, now we have started with chapter 5 of distributed computing principles and applications by MLEU. Thank you very much for your attention.